Hi, let's solve this problem. Write down the equation of each of the following straight lines and in each case give a direction vector. First part, it passes through this point and its slope is 2/5. Remember that the slope of a line is how much I go up, how much I go up over how much I go forward. Okay, so it will be always positive when we go upwards like this. So I can take this point and this point, for example, and the slope of this line would be how much I go up, that is this distance, over how much I go forward. If I take another point here, this proportion, the slope would be the same because these triangles are proportionals. Okay, knowing this, and remember, sorry I forgot, that when the line is like this, that it goes down, all right, the slope would be negative because we consider that how much I go up, since we go downward, is negative. Okay, let's work in this line. It passes through this point and its slope is this. The easiest equation to use here, because they don't ask you for a specific equation and you have 6 options, I would use the point slope form. That is y minus y coordinate of the point, which is 2 in this case, equals the slope times x minus the x coordinate of the point. You can know this by heart, or starting by the vector equation of the line, you arrive to this point, to this kind of equation. And then you have to calculate a direction vector of this line. Look, let's graph this slope. This slope is how much I go up, 2, 1 and 2, and how much I go forward, 5, 1, 2, 3, 4, 5. So my line will have this slope. Then it could be this line, this line. I just carry the slope to know the inclination. So this could be a directional vector of my line. And the coordinates of this directional vector are 5, 2. Let's move to the next line. The slope now is -2. And it is how much I go up over how much I go forward. Since we don't have a fraction here as a slope, it doesn't matter because this is the same than this. We can transform this very easily into a fraction. So it would be, let's graph this situation. How much I go up? -2. And I told you that we consider negative when we go down, over how much I go forward? Over 1. So this could be the direction of my line. This is the inclination. This could be the direction vector. So let's answer to the question of the vector first. And the coordinates are 1, -2. And now let's use another equation in this case. Let's use, for example, this form. That is the the slope-intercept form. That's because this is the slope and this is the y-intercept. It means where my line intercepts y-axis, so x equals 0. And it would be y equals m, in this case -2, x plus n. We just need to calculate the y-intercept. But we know a point that belongs to this line. So the coordinates of this point must satisfy this equation. So let's place these coordinates in the equation and we would obtain y coordinate 3, -2 times x coordinate, that is 1, plus n. This way we have a first degree equation and we can calculate the value for n, which is the y-intercept. So n would be, this is -2, that goes to the other side adding, n equals 5. So the equation of the line, in this case, would be this, and the direction vector. Let's move to the last case. It passes through point this, and its slope is 0. If the slope is 0, 0 equals 0 over 1. So it means, let's graph this situation in this case. We go up 0 and we go forward 1. So my line is horizontal, and my line passes through point 5, negative 1. Point 5, negative 1 is here. 1, 2, 3, 4, 5. And negative 1 is here. So this is my line. It is horizontal because the slope is 0. Okay, no inclination. And it passes through this point. So my line would be y equals negative 1. With this information is enough because every point in this line has coordinate y negative 1, right? And, the direction vector of this line. It could be, for example, this one that we drew before. That would be 1, 0, or 5, 0, or any number 0. I hope this was easy. Bye, see you soon.